In this video, we will understand the concept of surface area and volume. This particular video, we will focus more on the cubes and cuboids, and in the next video, we'll focus on other solids like cylinder, cone and sphere. So before we head to the concept, first understand the three major points here. First is the lateral surface area, also called as the curved surface area. So lateral surface area or curved surface area is, for example, if I have to, for example, this is a chalk, and if I have to just paint around it, if I have to just cover something around this chalk, leaving this above and the bottom surface, this is called the curved surface area or the lateral surface area. In case I have to gift wrap completely with the upper and the lower side also, and of course the boundaries of it, this is called the total surface area. And in case I have to find how much material is required here, or if I have a water bottle, how much water I can pour in it, the space occupied by a solid, this is known as the volume. So for this chapter, this is the concept of curved surface area, total surface area and the volume. Let's start with the cuboid first. So cuboid, as we all know, is a rectangle in 3 dimensions like this. So this is the length, width and the height. So the curved surface area, also known as the area of the 4 walls, is given by CSA is equal to twice of L plus B into H. Total surface area, if I have to just gift wrap this entire cuboid, it will be twice of LB plus BH plus HL. And the volume, that is the capacity of this cuboid, will be L into B into H. In case you are asked the diagonal of this cuboid, that will be root of L square plus B square plus H square. When we go for a cube is basically a cuboid, but it's a square in 3 dimensions. So all these sides, the L, B, H, all of them are same. So it looks something like this. So here the CSA, because now everything is square here, so each face has the area as A square. If A is the side, each face has the area as A square. So in CSA, because we are covering only the 4 sides or 4 faces, it will be 4A square. And TSA, because now we are taking all the 6 faces, this is called 6A square. And the volume, like we had here L into B into H, here will be A into A into A, that will be A cube. So this is how you can calculate the curved surface area, total surface area in case, and the volume in case of a cuboid and the cube. Now let us take a question to understand this concept better. The area of a playground is 3650 meters square. Find the cost of covering it with gravel 1.2 centimeter deep if the gravel costs rupees 6.40 per meter cube. So a playground is a rectangle. So we have to assume that a playground is in the shape of a rectangle. So rectangle, the area will be what? L into B. So L into B here is 3650 meters square. Now we are given that the cost is 6.4 per meter cube. When we see per meter cube, definitely we have to go for the volume. So volume, now when there is a playground and it will gain a height, like it is 1.2 centimeter deep, so it will gain some depth. So this will become now a cuboid. A cuboid volume is L into B into H. Now remember, this is in meter square and this is given in centimeter. So either we convert this in centimeter square or we convert this into meter. Now I would suggest you convert this into meter because the cost is given to us is in meter cube. So I convert this height as 1.2 upon 100, which ultimately becomes 12 upon 1000 meters. Now the volume of a cuboid is L into B into H. So when we put the values of L into B as 3650 and height as 12 by 1000, we get the volume as 43.8 meter cube. Now the cost is given as 6.40 rupees per meter cube. So for 1 meter cube the cost is 6.4 rupees. So for 43.8 meter cube the cost will be, we just multiply them and we get the answer as 280.32 rupees. So in this way you can solve more questions of this chapter. Now let us take one more important type of question here. That is, a closed rectangular box is made up of wood of 1.5 centimeter thickness. The exterior length and the breadth are 78 centimeter and 19 centimeter. And the capacity of the box is 15 cubic decimeter. Now remember, this is in decimeter and this is in centimeter. Find the exterior height of the box. Now most of you would get confused with the exterior height word. Now what is the exterior length and breadth and the exterior height means? For this, let's understand with the help of this box. Now what you see here is the exterior part, and what you see here inside, that is the interior part. So whenever we are given a capacity is always for the interior of the box because that is the volume that we are looking for. So here is the exterior part and this is the thickness. So assuming this is 1.5 and L and B are given to you, we are supposed to find the exterior height of this box. Now because we are given the volume, first we have to find out the interior dimensions of this box. So the L will be equal to 78 minus 1.5 minus 1.5. Now why we are doing it twice? As we see here, there is a thickness here and there is a thickness here. So exterior minus 1.5 from this side and minus 1.5 from this side. So here we have L is equal to 78 minus 3, which is 75 centimeter, and breadth is 19 minus 3, that is 16 centimeter. Volume is in decimeter, so we have to convert that into centimeter cube. For that we multiply 10 3 times because it is centimeter cube. And now we know that the formula of cuboid is volume is equal to L into B into H. So we just put the value of volume as 15,000, L as 75, B as 16, and that's how we find H as 12.5. Again, this H 12.5 is the internal dimension. So to get the exterior height, we have to add 1.5 on both sides. So 12.5 plus 1.5 plus 1.5, that gives us 15.5 centimeter. This is a very important question with respect to your examination. So please solve this question. Now let us take one more question which is based on the concept of area of cross section. It is again a very important question. Now the question says the cross section of a piece of metal of 4 meter in the length is shown in the figure. Calculate the area of cross section, volume and the weight if 1 centimeter cube is equal to 6.6 grams. Now first of all, what is the area of cross section? Now when we see this box, it is a cuboid, but when I see it from here, or if I cut it from anywhere from the from its face, you will see only a rectangle. So the cross section for this box, although if it is a cuboid, the cross section here is a rectangle. Similarly, there is a piece of metal whose cross section is this, but the length is 4 meter. So first of all, we have to just divide this in two parts. That is, we have made it one rectangle and I have joined it here, and this part becomes a triangle. So I have got two areas now. This A1 will be the area of rectangle and A2 will be calculated from the formula of a triangle. So this entire part is 12 centimeters. So this and this part is 7.5. So now we'll break it as this one will become 3.5 and this part becomes 7.5. This entire is 12. Again, this entire is 16. So because this is 10, this part becomes 10 and this part becomes 16. So first we calculate the area of rectangle, which is L into B. So 10 into 12 gives me 120 centimeters square. For the A2, that is area of triangle, which is half into base into height, we get the area as 13.5 centimeters square. Again, base here is 6 and height here is 3.5. So we add A1 and A2 and we get the area of cross section as 133.5 centimeters square. So we got the first part, that is area of cross section. Now volume. Volume basically means area into length. Area we calculated as 133.5 and length we have as 4 meters. Now remember, this is in meters and this is in centimeters square. So we have to use the centimeter unit for the calculation. So we make this as 400 centimeter. And when we multiply, we get the volume as 53400 centimeter cube. So we get the second part also, that is the volume in centimeter cube. The third part is weight of the piece if 1 centimeter cube is 6.6 grams. Now, because 1 centimeter cube is 6.6 grams and we have 53400 centimeter cube, so we multiply this and 6.6 and we get 352,440 grams. In the question, if it is asked, convert in the nearest kilogram. So first we convert that in kilogram by dividing this by 1000. So decimal shift to the third place. So it is 352.44 kg. And if we have to calculate to the nearest kg, then because it is less than 0.5, we make it 352 kilogram. The cross section questions are very important. They are pretty simple. They might look complicated, so don't leave them. Practice them. In the same way, you can solve more questions from the exercises.